All right, guys. Sorry about that. Little technical difficulties. Okay, I had to free up some storage on my phone. All right, so here's where we were. Okay, we just found that we knew the total resistance was 450. We knew the total voltage was 9 volts. Okay, so we had to figure out what times 450 equals 9, right? Because we remember that voltage equals current times resistance. So over here, 9 equals I times the resistance, 450. We divided both sides by 450. And so 9 divided by 450 gives us our current, which is 0.02. That goes here. Now, here is the beauty of this chart. We know that the current in a series circuit, right, one single loop, is the same everywhere. So if my total current is 0.02 amps, that means that all of my currents are 0.02 amps. Look at that. Just like that. Right? If you know one current, you know all of the currents. Okay? So again, with our resistances in a series circuit, we just add them all up. Boom, 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 boom. Our currents are always going to be the same. And now the only thing left to find is the voltage, which in this case, resistance times current equals voltage. So look at that. All you got to do is go across each row. 100 times 0.02 is 2 volts. Okay? 300 times 0.02, again, calculator on Google tells me that that is 6 volts. And 50 times 0.02 is 1 volt. All right? Now we have a completed chart. Now we know absolutely everything that you would ever need to know about this circuit. What is the voltage at the third resistor? Well, voltage, third resistor, is 1. What's the current at the second resistor? Second resistor, current, is 0.02. What's the resistance at the first resistor? Resistance, first resistor, is 100. Okay, so you can answer whatever question. The other beautiful thing about this chart is that it allows you to double check everything. So look at this. Your resistances always add up. 100 plus 300 plus 50 equals 450. Check. Your currents are always going to be the same. 0.02, 0.02, 0.02, 0.02. And lastly, we said that the voltage drops over every resistor. So that means each resistor gets a piece of those 9 volts. So your voltages also add up. 2 plus 6 plus 1 is 9, right? The bigger the resistor, the more voltage it eats up. The 300 ohm resistor eats up 6 volts, where the 50 ohm resistor only eats up 1 volt, all right? So we're gonna look at one more example. Let me make sure we're still rolling here. I don't wanna lose it. Okay, good. So we're gonna do one more example, just so you can see how this looks. So I'm gonna draw this circuit real fast. Let's say we have a 10 volt battery. It's coming out, and this one only has 2 resistors. 1, 2. This is very poorly drawn. Let's say I know that the first resistor is 1 ohm, and let's say I know that the total current, or the current in that second resistor, is 5 amps. Okay? So we're gonna do the same thing. VIR. We make our VIR chart. First thing to do, write that down. Second thing, count your resistors. 1, 2. That's Dante. Roar 1. R2. And lastly, our total. Draw lines. Is that being helpful? I think it is. All right. So label everything we know. Number 1, we know that this battery has 10 volts. So the battery is always your total voltage. Okay, and I know my resistor for the first resistor is R1, is 1 ohm. Okay, and I know the current in the second resistor is 5. So if you're playing along, this is what you should have had, okay? And from here, I can find out everything about this circuit. All right, so same thing. First place I look is I know that the current is the same everywhere. So if the second resistor gets 5 amps of current, that means the first resistor gets 5 amps of current, which means that the total resistance is 5 amps of current. The current in a series circuit is the same everywhere, okay? Now we also know that voltage equals current times resistance. So any row where you have two numbers, you can always find the third. Here we have 1 times 5 equals our V, which is 5. Ah, that's an A. 1 times 5 is 5 volts. All right? Down here, I know that the resistance times 5 is going to equal 10. So I use this. Here's my equation. 10 equals 5 times R. I divide both sides. This is multiplication, so I do the opposite. 5 divided by 5 is 1. 10 divided by 5 gives me a resistance equal to 2. So this is 2 ohms, okay? I know that my resistances have to add up. So 1 plus blank is 2. You guessed it. This one also has to eat up as 1 ohm of resistance. And I know 5 plus blank equals 10, which means that this has to be 5. And again, you can double check all of this. You go down each column. 1 plus 1 is 2. All of my currents are the same. And my voltages add up. 5 plus 5 is 10. Go across each row. 1 times 5 is 5. 1 times 5 is 5. 2 times 5 is 10. And that's it. Okay? If you use this VIR chart, you will be able to answer any question about any circuit. Okay? So, quick recap. Number 1, a series circuit is one loop. Okay? If any point of the circuit fails, the whole thing fails. Okay? Meaning that if this resistor, if this light bulb dies, okay, the whole circuit dies. Everything. If you own some old Christmas lights, you'll know this. If one of the bulbs goes dead, all the lights go dead. You have to go through them. You have to find that one bulb that's broken. That's a series circuit, okay? They're easy to make. They're cheap to make, but they are not super efficient because if one thing in it dies, the whole thing dies, all right? Meaning like if this was your house and one of your lights goes out, it means all the electricity in your house would go out. So, spoiler, your house is not wired in series, all right? It's one loop. One single loop, all right? The second thing you need to remember is your voltage, your current, and your resistance. The current is the same everywhere. The voltages add up, and the resistors add up. The bigger the voltages add up. The bigger the resistor, the more voltage it eats. And just remember the chart. Voltage equals current times resistance. Number all of your resistors. If there's only 2 resistors, you only have R1 and R2. There's a total for everything, and use the chart, okay? If you have any questions, go on the Google Classroom and underneath this heading, it'll say series circuits, just comment. Whatever questions you got, try to phrase them in a comment there and I will get back to everybody today to answer whatever questions you guys have. All right? All right, guys, well, that's it for our first video. Again, just put comments on the Google Classroom and I will see you guys on Friday.